In this course, we will be learning the basic method of using a servo drive, how to use the Sigma Win Plus version 7.43 support tool, using the Sigma 10 servo drive with analog voltage/pulse train reference as an example. Step 1. Installation and wiring. Step 2. Setting up the Sigma 10. Step 3. Trail and operation. Step 4. Tuning. The materials related to this course are available at Yaskawa's e-Mechatronics website. Refer to the Peripheral Device Selection Manual for information on selecting the cables and other components. In Step 1, we will learn about the installation and wiring. 1. Mounting the servo pack. 2. Mounting the servo motor. 3. Wiring and connecting the servo drive. 4. Connecting I/O signals. 5. Connecting other connectors. In this section, we will learn about the mounting of the Sigma 10 servo pack. The environmental conditions for using the servo pack are given in the table. Always observe the environmental conditions, such as surrounding air temperature, surrounding air humidity, pollution degree, and altitude. Servo packs are available in the following mounting types: base mounting, rack mounting, and duct-ventilated mounting types. Servo pack must be mounted vertically. The base-mounted servo pack is mounted to the wall inside the control panel. The rack-mounted servo pack fits into rack located inside the control panel. The duct-ventilated servo pack is mounted so that the heat-dissipating section of the servo pack is inserted into a ventilation duct. Heat can escape from the servo pack into the air pressure through the duct. The spaces for mounting base-mounted and rack-mounted servo pack are defined for each servo pack. Please conform to the mounting space conditions for the servo pack that will be used. Take into consideration the convection of heat inside the control panel and consider installation panel, if required, so that hot spots do not occur inside the control panel. In this section, we will learn about the mounting of the Sigma 10 servo motors. The environmental conditions for using the servo motors are given in the table. Always observe the environmental conditions, such as surrounding air temperature, surrounding air humidity. The rotary servo motor relies on the mounting section of the machine as a heat sink to dissipate heat. The heat dissipation conditions are defined by the size of the mounting section, which is assumed to be aluminium. If the heat dissipation conditions are not satisfied, the servo motor temperature may rise considerably. Ensure that the mounting mechanism satisfies the heat dissipation conditions. The servo motor can be mounted horizontally or vertically. There are 3 points of caution when mounting the servo motor. The first point is that you must be careful not to subject the shaft to the motor or the area around the encoder to a strong shock when mounting it. The second point is that the servo motor must be mounted so that the radial load and thrust during operation do not exceed the specific values. The third point is that the servo motor must be mounted to the machine so that centering accuracy falls within the specified range. In this section, we will learn about the wiring and connecting the servo drive with analog voltage/pulse train references. There are 2 power supplies for the servo pack: the main circuit power supply and the control power supply. For a servo pack with a 3-phase, 200-volt AC power supply input, connect the main power supply to L1, L2, and L3 terminals, and the control supply to L1C and L2C terminals. Create the power on sequence in the following manner. First, turn the control power on. After the servo alarm output signal goes off, turn the main circuit power on. Based on the timing chart, create the actual circuit like the diagram display on the screen. The alarm signal is received by the relay and added to the conditions to turn on the main circuit power. When the alarm is cleared, the main circuit power turns on. When using multiple servo packs, create circuits with a relay to receive the alarm output signals. Use the output signals from the relay in control circuits to interlock the main circuit power supply to the servo pack. As a countermeasure against electrical noise, connect a noise filter and ground the circuit according to the manual. When creating the power supply circuit, take into consideration the characteristics of the machine, control specifications, and compliance with safety standards. Special cables with connectors are available for the servomotor main circuit cable and encoder cable. Connect the servomotor main circuit to the U, V, W, and ground terminals on the servo pack. Connect the encoder cable to CN2 on the servo pack. When using a servomotor with brake, the brake is controlled by a signal from the servo pack CN1 connector. Allocate the brake output signal with the parameter PN50F, explained later. The allocated output signal is a relay, which switches the secondary side of the holding brake power supply. Connect a surge absorber or diode close to the brake terminal of the servomotor. In this section, we will learn about the I/O signals of the servo pack. Connect the host controller and external device to the CN1 connector using I/O signals cable. The I/O signals of the servo pack include input signals by analog voltage, input signals by pulse train, and 24 VDC I/O signals. Refer to the product manual for the names and functions of the I/O signals. Now, let's take a look at the input signals. Analog voltage input signals are used to input the speed reference and torque reference as analog voltage. The maximum allowable voltage for the input signal is plus or minus 12 volts. Pulse train input signals are used when specifying the position and speed as pulse train. The servo pack can receive 5-volt differential line driver output or open collector output signals. 3 forms of reference pulse signals are accepted: sine and pulse train, CW and CCW pulse train, and 2-phase pulse train with 90-degree phase offset, also known as quadrature. Use PN 200 to select the required format. Allocate the general-purpose sequence input signals to the servo pack to pin numbers 40 to 47 on CN1 connector. Change the setting values of the parameters to change the allocation of the input signal from the default settings. Sequence input signals can be syncing or sourcing. To use the sequence input signal as syncing, connect pin number 47 on the CN1 connector to 0 volts. To use the sequence input as sourcing, connect pin number 47 to plus 24 volts. Now, let's take a look at the output signals. The output signals from the servo pack include the encoder divided pulse output signals, absolute encoder position signals, servo alarm output signals, general purpose sequence output signals, and alarm code output signals. Position information feedback is output from live 5-volt differential line drivers from the servo pack as the divided pulse output signals. Use line receivers to receive these signals at the host controller. Connect the differential signals of the host controller to the servo pack and connect the signal's grounds. A 2-phase pulse train with phases A and B 90 degrees out of phase is output to the host controller as position information. A photocoupler output circuit is used for the servo alarm output signal. Connect a load to the collector side. Photocoupler output circuits are also used for 3 general-purpose sequence output signals. The 3 alarm code output signals are open collector outputs. Connector 0 volt of the I/O power supply to the signal ground. When an output signal is connected to an inductive load, such as a relay coil, attach flywheel diodes to both ends of the relay coil to suppress surges.